Well, another really interesting fact about sine, cosine, tangent, secant, cosecant, cotangent functions is that they are periodic. And what does that mean? Well, that means that if I were to find a sine or a cosine or any of these trigonometric functions of a certain angle, I could pretty much be assured that if I had any angle that was coterminal with the angle I was dealing with, I would be able to find it. Let me give you an example right here. Let's let t equal negative pi. Where will we find negative pi? Well, negative pi would be a rotation in the clockwise direction, but it happens to be coterminal with the angle pi, right? We know that it's coterminal. Let's see, it's at the point 0, negative 1, comma, 0. I'm reading too fast. Negative 1, 0 here at negative pi. So let's take negative pi and get a coterminal angle by adding 2 pi. That gives us positive pi. And we know that if we have a central angle at pi, we still end up at a coordinate on our unit circle corresponding to negative 1 and 0. So, using that coordinate point, we can define all our other trigonometric functions of negative pi because, well, they correspond to pi. Saying something like sine of negative pi is equivalent to stating the sine of pi. Because it's periodic, the difference between the two angles is 2 pi, then both of these will equal 0. And we can go on and say the same thing about the rest of our trigonometric. For instance, the cosine of negative pi is equal to the cosine of pi. They're both equal to negative 1, which is the x-coordinate at that position. And the tangent of negative pi is equal to the tangent of pi. Remember, sine divided by cosine gives us tangent, and that's equal to 0. Well, 0 over negative 1, that's 0. Likewise, if we take the cosecant of negative pi, it's the same thing as the cosecant of positive pi, which is 1 over 0, making it an undefined value at pi, or negative pi. Taking the secant of negative pi is equivalent to taking the secant of pi, since they're 2 pi apart. Our result is negative 1. And taking the cotangent of negative pi is equal to taking the cotangent of pi. Those are both negative 1 over 0 and undefined, just like cosecant was. One other quote-unquote fun fact about sine and cosine functions is that we can also classify them as being even or odd functions. For instance, I guess we could think of things like this. If we say cosine of negative t, it's equal to the cosine of t. How do we know? Well, let's go back to an example that we did earlier. We had said at one point when we were looking at a right triangle here, when we built a right triangle in our first quadrant that contained the angle pi over 6, we noted that our x-coordinate, radical 3 over 2, represented the cosine. Well, if we were to build an angle in the fourth quadrant here, and let's say we were just talking about the rotation in the negative direction, so negative pi over 6, what would we say about the cosine there? That is the x-coordinate. Well, its x-coordinate would also be positive radical 3 over 2. That makes this an even function. Cosine of negative pi over 6 is equal to the cosine of pi over 6. Consequently, the secant of negative t is also equal to the secant of t. These are the only two functions that we say are even. If you remember, even functions were the kind of functions where f of negative x was exactly equal to f of x, a fact which we'll run into later. The other functions, sine, cosecant, tangent, and cotangent, are all odd functions. So if we have an odd function right here, we could say that if we took the sine of negative t, it would be the negative of the sine of t. What we mean by that, let's take our angle pi over 6 again. We know if we're in the first quadrant, positive 1/2 is the value of our sine, whereas negative 1/2, if we're at negative pi over 6, is our sine. So what could we say? Well, since the sine of negative pi over 6 would give us negative 1/2, it is the opposite of the sine of the angle positive pi over 6, which is positive 1/2. So we take the negative of that. In other words, the negative of sine pi over 6 is the same as the sine of negative pi over 6. All of these other functions, cosecant, tangent, and cotangent, are just like that. So what could we say right here? Well, if we're given the value of the trigonometric function, let's say we're told that cosine of negative t was equal to 1/5. Since we know that cosine is an even function, then our cosine of t must also be equal to positive 1/5 because it's an even function. How about secant of negative t? Well, if cosine of negative t is 1/5, don't forget that will be the same as saying 1 over the cosine of negative t. And we know that value to be 1/5. Therefore, the secant of negative t should equal positive 5. But that's should be pretty straightforward to understand.